Hello, Thermodynamics Lecture 2. Thermoelectric motive force. Thermo Thermoelectromotive force. When two junctions of a thermocouple are placed kept in different temperature, then thermo EMF produced between the junction, which charges which changes with the temperature difference between the junction, that is thermo EMF. It is a thermocouple and this is the hot junction and this is cold junction and this will be placed to hot junction. Then the thermoelectromotive force will develop, that known as E is equal to AT plus BT square, where A and B constant for pair of metal. In case of thermocouple, there is a two metals are used. Then the temperature is at junction T is equal to ET by E100 into 100 degree 100 degree centigrade, where E100 the temperature of hot junction at 100 degree centigrade. A thermometer can measure temperature ranging from minus 200 degree centigrade to plus 1600 degree centigrade. Thermal equilibrium. Thermal equilibrium. When there is no transfer of heat between two bodies in contact, the bodies are called in thermal equilibrium. This body will contact with this, then there will be no flow of heat from this body to this body or this body to this body. Then they are thermal equilibrium. Zeroth law of thermodynamics. if two bodies if two body A and B if two bodies A and B are separately in thermal equilibrium with a body C, then the body A and B will be in thermal equilibrium with each other. If two body A and B are separately in thermal equilibrium with a third body C, then the body A and body B will be in thermal equilibrium with each other. Triple point of water. The value of a pressure temperature at which water exists in equilibrium in all three states of matter. Water vapor called triple point of water. Means there is existence of three phase in particular point, that is known as triple point. The value of a pressure and temperature at which water coexist equilibrium in a three state. Water and vapor called triple point of water. Triple point of water 273 Kelvin, temperature and 0.46 centimeter of pressure. Specific heat. The amount of heat required to raise the temperature of a unit mass of substance through 1 degree is called specific heat. Amount of heat required to raise temperature of specific amount and raise of 1 degree centigrade. It may be denoted as C or S. SI unit of heat 0 degree centigrade, joule per kilogram per centigrade. Specific heat of water. Specific heat of water 4200 joule per kg per centigrade. or 1 calorie per gram per centigrade. And with a with a high which high compared with most other substances. Gases have two types of specific heat. First, the specific heat capacity at a constant volume denoted as CV. Second, the specific heat capacity at a constant pressure, that is Cp. Specific heat at a constant pressure Cp is greater than specific heat of constant Cv. Cp greater than Cv. For molar specific heat, molar specific heat Cp minus Cv is equal to R, where R is equal to gas constant the the ratio of two principal specific heat of gas represented by gamma. Gamma is equal to Cp by Cv. The value of y, the value of gamma depends on atomicity of gas. Amount of heat energy required to change the temperature of any substance Q is equal to mc delta T, where m is equal to mass of substance, C is equal to specific heat substance. Delta T is equal to change in temperature. Then thermal capacity, thermal heat capacity. Heat capacity of any body is equal to amount of heat energy required to increase its temperature through 1 degree 1 degree centigrade. Heat capacity is equal to mass m into c, where c is equal to specific heat of substance, m is equal to mass. Its unity, SI unity, joule, joule per Kelvin, J by K. Water equivalent. It is the quantity of water whose thermal capacity is same as the heat capacity of body. It is denoted by W. W is equal to ms is equal to heat capacity of body. Latent heat. The heat energy absorbed or released at a constant temperature for unity mass for change of state is called latent heat. The heat energy absorbed or released at a constant temperature for unity mass of change of its state is called latent heat. Means this is a one state solid state, then it will start melting and the temperature will be constant. That is latent heat. If it is liquid, then boiling, the temperature will be 100 degrees. To change from liquid state to gas state, that is latent heat of heat absorbed or released. Heat absorbed or release during the change of state. Q is equal to ml. M is equal to mass of substance, and L is equal to latent heat. For water, it's the normal boiling point or condensed temperature 100 degree. Latent heat of evaporation L is equal to 540 calorie per gram or 40.8 kilojoule per mole or 2260 kilojoule per kg. For water, it is normal freezing temperature or melting L equal to 80 calorie per gram or 60 kilojoule per mole or 336 kilojoule per kg. It is more painful to get burnt by a steam rather than by boiling at 100 degrees centigrade. Get converted to water at 100 degrees centigrade. Then it gives out 536 heat. So it is clear that steam at 100 degrees centigrade has more heat than water 100 degree boiling water. After snowfall, the temperature of atmosphere becomes very. This is because the snow absorbs heat from the atmosphere to down. So, in mountain, when snowfall, one does not feel too, but when ice melt, he feels too cold. This is more severing effect of ice cream on teeth as compared to water obtained from ice. This is because ice cream down it absorbs large amount of heat from teeth melting. Conversion of solid into liquid state at a constant temperature is melting. Melting means solid to liquid. Evaporation. Conversion of liquid to vapor at all temperature, even below boiling point, is called evaporation. Boiling. When a liquid heated gradually at a particular temperature, saturated vapor pressure of the liquid becomes equal to atmospheric pressure. No bubbles of the vapor rise to the surface. The process is called boiling to liquid. The temperature at which liquid boils is called boiling point. The boiling point of water increases with increased pressure and decreases with a decrease in pressure. Sublimation. The conversion of solid into vapor state is called sublimation. There is no intermediate state and solid to direct vapor, no liquid. That is called sublimation. Calorimetry. This is a branch of heat transfer that deals with a heat. The heat is usually measured in kilocalorie. Principle of calorimetry: when hot body mixed with a cold body, when heat lost by hot body equal to heat gain by cold body. So we can write heat lost is equal to heat gain.